Alrighty, Patriots, in the last lesson, we learned about the 5 properties of a parallelogram. We said a parallelogram is a special type of quadrilateral. A quadrilateral is a polygon with 4 sides. So we have a special type of parallelogram that is called a rhombus. So all properties of a parallelogram are going to apply to a rhombus, but some of those properties are going to get more specific. What I mean by that, so in a parallelogram, both pairs of opposite sides are parallel. Well, a rhombus is a parallelogram. A rhombus is a parallelogram. So if you're looking at that like in a Venn diagram, we could do something like this, where we have, here are all of my p grams, and inside of that is a rhombus. Every rhombus is a parallelogram, but not all parallelograms are a rhombus. And I'm going to give you a flow chart that's going to show that. So both pairs of opposite sides are parallel for a parallelogram. So that still has to be true for a rhombus. So both pairs of opposite sides are parallel. So left is still parallel to right, just like with any parallelogram. So RB is parallel to segment HM. They go the same direction and don't touch. Not only is left parallel to right, top is parallel to bottom, just like in all parallelograms. So this is still true for a rhombus. So RB is parallel to HM, left is parallel to right. RH on top is parallel to the bottom BM. Well, what separates a rhombus from the rest of the parallelograms? It's this property right here. Both pairs of opposite sides are congruent for all parallelograms. Left is, did I say parallel? I meant congruent. Both pairs of opposite sides are congruent. Left is congruent to right. But because this is, so that's true for a rhombus, but because it's a rhombus, all of my sides are congruent. Okay, so I still have both sides are congruent. Notice I've got a rhombus right here. They told me it's a rhombus. We got to know it's a rhombus. Both pairs are still congruent. Left is still congruent to right. Top is still congruent to bottom. However, we're a little more specific now. All my sides are the same. That's what makes this a rhombus. Left is congruent to bottom, is congruent to right, is congruent to top. Segment RB is congruent to segment BM, and that is congruent to segment MH, and that's congruent to segment HR. All of my segments are congruent. It still applies to that rule for parallelograms. In a parallelogram, both pairs of opposite angles are congruent because this is a parallelogram. Angle H is congruent to angle B. Angle R is congruent to angle M. And in a rhombus, that doesn't change. Both pairs of opposite angles are still congruent. So we've got bottom left, top right, top left, bottom right. That is still the same. Okay. Again, though, oops, that should be in yellow. We have to be told it's a rhombus. Okay, so in a parallelogram, when I draw in the diagonals, what it does is it cuts a corner in half. So it would take corner R and it would cut it into 2 pieces. It would take corner M, cut it into 2 pieces. Same with this corner and this corner. Now, but because this is a rhombus, the diagonals bisect opposite angles. And remember, bisect means cut in half. So what I'm telling you is the purple angle got cut into 2 equal parts. So all these green pieces are going to be the same. The blue angle got cut into 2 equal parts. So I know 1 green equals all the greens. And if I add the greens together, I'm going to get a purple. 1 orange equals every other orange. Add the oranges together, and you get a blue. These are the rules because of the diagonal in a rhombus. There we go. And then add, equal, add, equal. So those are the rules that we can say. Angles, because it's still true, diagonals still got, these angles still got cut into 2 pieces. That's what happened in a parallelogram. However, these angles were now bisected. In a rhombus, my angles are bisected. If I give you a rhombus, we know that to be true. All right? Consecutive angles are supplementary. In a rhombus, they're still supplementary. So because I have a rhombus, what colors do I use on those angles? I want to use the same colors. Purple. Oh, I use blue over there. It don't matter. No, it doesn't. Because I've got a rhombus, any green angle plus any purple angle is 180. Because supplementary means add up to 180. Consecutive means that they are on the same side. Consecutive angles are supplementary. 2 angles on the bottom add up to 180. 2 angles on the right add up to 180. 2 angles on the top, 2 angles on the left, all add up to 180. This is the so diagonals still bisect each other. The diagonals cut each other in half. Nothing special about that. So we have a rhombus. So the diagonals are cut in half because that's what happens for any parallelogram. So the 2 green pieces are going to be the same. Add the green pieces together, get a blue piece. The 2 purple pieces are going to be the same. Add the purple pieces together, get an orange piece. The diagonals bisect each other. There we go. Let's get all this in. Let's get in my colors first, and then we'll fill it in. So I know green equals green, green plus green equals blue, purple equals purple, purple plus purple equals orange. There we go. So green, RS, the length of RS equals the length of segment MS, and the length of RS plus the length of MS equals the entire diagonal. RM, part plus part equals whole. The length of segment BS is equal to the length of segment HS. And if you add the 2 purples together, HS plus BS, that equals the whole diagonal, BH. Oh. It's still true. Diagonals bisect each other. Diagonals bisect each other. Now, in a parallelogram, diagonals just kind of intersect each other. This is brand new for a rhombus. For a rhombus, diagonals will always be perpendicular. That means when these diagonals cross, it makes a right angle. So my diagonals are going to cross and make a right angle. So segment RM is perpendicular to segment BH. What that means for us is we have 4 90-degree angles, 90 degrees, 90 degrees, 90 degrees, 90 degrees. All right, so a rhombus, got to know all your properties. So it has all the properties of a parallelogram. It has those 5 properties, but it added some new ones. The diagonals are perpendicular. That's specific just to a rhombus. Nothing new here. My consecutive angles are still supplementary. My diagonals still bisect each other. What is new is when I draw in the diagonals, we cut angles in half. And in a rhombus, all four sides are the same. If I give you a quadrilateral with 4 equal sides, you know you have a rhombus. Okay, so a quadrilateral with 4 equal sides is a rhombus. So if you look at your bell work, flip back there. I want you to determine if each of the properties applies just to a parallelogram, just to a rhombus. Does it apply to both a parallelogram and a rhombus, or does it apply to neither of them? All right, so you're going to pick, is it just a rhombus, just a parallelogram, both, or neither? If you have any questions, make sure you ask so we can get those points cleared up. And we'll see you when we see you, Patriots.